Our project title is Advanced Data Management in Remote Oil and Gas Environments Using Edge Computing. The project addresses the critical challenges faced by the upstream sector of oil and gas industries concerning the management of vast real-time data volumes generated at remote drilling sites. To tackle the obstacles, our solution gathers the sensor data at the remote sites using edge devices and transferring it to the AWS sitewise and leverages the Lambda and digital twin capabilities to the getting the real-time analysis and data processing using the cloud edge collaboration. So here we are using two Raspberry Pis, Raspberry Pi 4 and Raspberry Pi 3B Plus. Here the Raspberry Pi 4 acts as an edge device where the Node-RED software is installed for the virtual flow of physical assets, and it is connected with the ultrasonic sensor and it is also connected to the DHT11 sensor. Coming to the Raspberry Pi 3B Plus, we are installing the Greengrass IoT, which is used further to connect to the AWS sitewise. We are using Putty and Real VNC Viewer software to replicate the screen of Raspberry Pi 4 in our local computer. Now coming to the Putty software, we need to enter the Raspberry Pi 4 and need to enter the required credentials which are necessary to provide during the initialization of Raspberry Pi 4. And now we have to enable VNC server in virtual mode using the command VNC server virtual, which gives a IP address. By entering this IP address in Real VNC Viewer with required credentials, we can visualize the Raspberry Pi 4 screen on the monitor. So we can see the monitor here by entering the credentials. So in the Raspberry Pi desktop, open installed Node-RED software that starts the Node-RED services. As shown here, the flows are getting started and an IP address is generated to view the Node-RED workspace. In the browser, by entering the IP address, here we can see the flow that has been created, where in this flow, majorly we are using an RPISRF node with ultrasonic sensor pin connectivity information. Similarly, the DHT11 node is used to get the temperature and humidity. These outcomes are set as global variables using functional node. By connecting debug node to the functional node, we can see the temperature and humidity in the debug window. Now to visualize these outcomes, we use GAS nodes, which gives the preview in the dashboard by entering IP address /UI. The OPCUA server node, which is used in the flow, helps to transfer and enable machine-to-machine communication. By seeing this node, it dedicated with a port number which has endpoint URL in Discovery tab. And then now opening OPCUA client software and enter the endpoint URL in the new tab, so that we can observe the objects tank 1 with parameters temperature and humidity. To view this data, create a data view, drag the parameters and drop in workspace. At the end, using this endpoint URL, we can connect IoT sitewise and visualize this data further for the project extension and digital twin making.